Okay, good. Welcome to the 11th week, and today we're gonna watch the book, Scratchapixel. You have the link. We're gonna spend 10-20 minutes with the basics of, not the basics, the technical basics of ray tracing and computer graphics, which are super useful. Now that you are motivated to do great movies, now it's a great time to show you the technical details, not the other way around. And also we have the strawberry. How is it going, the strawberry? 50% completed? 50%? Who has completed 50% of the strawberry? Who has the dots, the seeds? Who has the seeds? Okay, that's a lot. Now what you're gonna do, you're gonna put the leaves. You don't need to make the super complicated leaves, just put some square, couple of rhomboids, triangles that look like a leaf. It's enough. You sent me a strawberry? What? Let's see Raya's strawberry. Private or in public? No, share in public. Talk to me because I don't see you. Chat to me. I am here. Very good. Is this a strawberry? Let's see. Did you put music on it? You know, music is 50% of the movie, so. Do you see it? No, you cannot see it. Hold on. Okay, sorry, I thought you could see it. $1097. I'm gonna show you Raya's strawberry. Wonderful. Okay, that's your strawberry. Wow, it's very beautiful. Wow, look at that. You cannot see it? Hold on. IT in this college became very complex. What about now? You cannot even see it. Here. I'm going to move it to this screen here. Wow, you cannot see nothing. I mean, look at this. It looks good, no? It looks like a pineapple. No, that comment is not helpful for her. It will not help her improve the strawberry. So it's much better we say now, feedback she can improve. Yes, that's what they do at Pixar. Okay, what feedback do you want? Oh, it's beautiful, great, or? Okay, so how could we improve this strawberry? Let's watch it again. Hold on. From this angle, it looks very squarish, right? So it reminds me of a pineapple a bit. So that could be fixed, right? If we make it more triangular, right? Does it make sense?
I think I meant to make it like that because I think it's not realistic. Because I never ate a perfect strawberry.
I'm sure there are strawberries like that or worse. I agree with you. The problem is the uncanny valley. Strawberries. Because you're already pushing the limits with the color. It's not the real color. So if the shape doesn't look like a strawberry, then it becomes creepy. Does it make sense? Well, not creepy, but pineapple shape. Hold on. So here you have some strawberries. It cannot be. The prototypical strawberry has this nice kind of hearty shape. I would say this one is really nice. Wedge? What is this? 60? So you cannot take advantage of that, and it will look so much better, I think. Yeah. And the seeds are kind of green, right? And in the video they make what? Yellow?
I think I saw it in some picture
Maybe it will help if you make it a bit greener. I don't know, just play with it. Is it easy for you to change the color of the seed?
I will try.
Okay, these little things, just a small detail can say, oh yeah, now it looks like a strawberry that I could buy in the supermarket. What else could she do to improve?
The color.
The color, yeah? How would you change it? Now it looks like perfect red, right? What would you do?
Maybe make it lighter. Maybe shade it more.
Make it more imperfect, you mean? Is that what you mean? Yeah, we could do a mapping. We have not seen that. We will see later. But you could map some irregular color pattern into the strawberry so it doesn't look too perfect. That's very good. Okay, well done, Raya. So that's finished. Okay, then we will compare everybody's strawberry and we'll make a competition. Whoever gets the most realistic strawberry award, you get a bonus point. Okay? Got it? Awesome. Okay. So let's watch the first chapter of the book. Yes? Very quickly. And then you'll have 40 minutes to continue with the strawberries and ask me questions. Okay? So you can follow the book chapter by clicking on the link on Slack. So if you go to General, this guy here, if you click here, you can open a link that will lead you here. I don't know who made this book, but it's one of the best books I've seen. Many books are really, really technical, but this one has a very good balance between technical and non-technical stuff. The first part, we saw some concepts like interpolation, matrix inverse. So this part is great. If you're not familiar with the vectors that we saw at the beginning of the course, you can check these, and there's the definition of a vector and stuff like that. So it's really good to review. Sounds good? But if you are familiar with vectors or you don't have any doubts or anything, just skip it. And we go to volume 1, and we go to the first part, which is, we're going to see this today on this one. So we're talking about ray tracing here. And the question starts with, how do you create an image inside the computer? So usually you'll have a viewing point, some object, and this, which represents the screen, the cinema screen or the computer screen, we call this the canvas. Make sense? So the camera would be here. It's like, if I'm doing this, that's my screen. Does it make sense? That's my vantage point. That's where the camera is. That's what it is. I'm going to move this a bit. I'm going to move this to this side, and I'm going to stop the radioactive light. Great, excellent. So that's very easy, right? So because we know that how an image is projected into our eyes. We have this little hole, remember? And then it crosses and it projects here. The camera is the same. So we can simulate this process inside the computer by doing a projection on the canvas, which is what's you are seeing here. Does that make sense to you? Yes? Everybody? You believe this? Maybe in school you built a similar thing, which you took a toilet paper and you put a semi-transparent thing and you make a hole and the image was inverted. Did you do that at school? It's called a camera obscura. No? Haven't done that? Oh, okay. Well, if you have small kids or if you have small kids, it's great. Art project. Let me show you one. If I can, here. If I can Camera Obscura project. There are many ways to do this with WC paper roll. Yeah, here's one example. So here's a few people that made this Camera Obscura. Here's one. Here is another one. So you take a toilet paper and you put a semi-transparent piece of paper and on both sides, and you make a hole in one of the sides, and then on the other side it will be the inverted image, and that's how cameras work. Let's see if I can show you a better picture. That's another example. Yeah, this one, short video. Yeah, here. Yes, yes. Just show me the camera. Let's see here. Wow, took a long time.
If you're a subscriber, thanks for subscribing.
No, not a very good tutorial. This one. Let's see. Yeah, not very good. And the internet is very slow. Anyway, so we did, in Spain, we all do this project at school. So you take a paper roll, and one of the sides is this semi-transparent paper, and the other side is just normal paper, and you make a hole, and then the rays of light will just cross, and then on one side you see an inverted image upside down, which is how your eye works, because your eye has this hole, and so on. Cameras work like that. Got it? So the only difference with this thing and your eye is that your eye has the retina here. So that would be the lens of your eye. And the image would be projected here inverted. And you see it right because you are used to it. But inside your retina, the image is inverted. Does it make sense? In the computer, we don't need to do that. We just need to say, hey, if there was a TV screen or this thing, we put it here because we don't need to do all this complication. We say, okay, we project in a flat surface, and that's what we will show to the people. But it's the same thing. Does that make sense to you? Yes? So basically, we are simulating the eye inside the computer. And because it's a computer, we don't need to do this complicated stuff because we can do it here, the projection. Yeah? The process is to project 3D into 2D, which also means you will lose information. Make sense? Cool. So this is one thing. So how does this work? And I think do you know this guy, Ibn al-Haytham? How do I pronounce this? Thank you, thank you. When was he born?
1965.
How many years ago? No calculator. 1,000? No. What does? Oh yeah, 1,000. Yeah, okay, 1,000 years ago. Wow, 1,000 years ago. If you had studied this class 1,000 years ago, you'd be rich now. So he discovered, how do we see images? So he basically realized that you see images because light of the sun bounces to an object, and the ray goes into your eye.
It's the opposite of this. We project our light, then.
You project light from the eye?
Yes. Well, I saw a video about it.
Okay. Who thinks it's better to project, to see things like this? Raise your hands. 1, 2, 3. Who prefers?
Every object has its own. There's some light, but we project it. No, we don't project it.
Okay, who prefers the Shire method?
No one.
Okay, interesting.
I can show you after.
Yes. So this is one way to see things. The other way to see things is what Beshayer is saying. Let's see. So you go here and you click here in the next chapter. We'll see Beshayer's method in a minute. Okay, so basically what happens with the sunlight is like one photon, you know photons, right? Yeah, will hit and then it will scatter into random directions, and many, many photons will scatter in different directions. That's how it works, more or less. We don't understand very well how it works, but because it's quantum physics, so nobody understands very well, right? So depending on the surface, you will have more scatter or less scatter, right? So if I have a very, very shiny surface, will I have more scatter or less? A very, very smooth surface. So when a photon hits a surface, it usually bounces, you know, like a ping pong ball, but not all the time. Because the surface, it looks flat, but it's not. Like your laptop surface, do you think it's flat? It's not. If it was flat, it will look like a mirror. Does it look like a mirror? No, then it's not flat. It means microscopically there's something. And if you look with a microscope, you will see some weird stuff there. Does this make sense? You will see something like that. Or like that. Or like that. And that's what it gives this look, not mirror. Yes? That's very cool. So here's what Beshayer was saying. The other way to make an image inside the computer, or to know how something will look like in your eye, is to do the opposite. Instead of computing all the rays of light that will go into your eye, look from your eye, what can your eye see, and trace it to the source of light. So there's two ways to build this projection in front. Remember the first picture of the, yeah? So this is called ray tracing, and you can do it. Start from the light or start from the eye. Doesn't matter. Well, we'll see later that it matters, but you can do it both ways. But in the real world, I think the first one is correct. Yes? Cool. Another one. Right, so this is the same idea, right? So if we do her method, this is not how the physical world works, but for the computer, it's the same. You throw a ray of light from the eye, or the camera in this case. You do it for all the directions. So here we have only 1, 2, 3, 7 by 7, 49 rays. And see where they hit, right? And say, okay, good, it goes like this. So how much light is that? 5, 10, 20, I don't know, whatever measure. And then you put it in this matrix. Next one. How much light or shadow? Boom. Does it make sense? And that's how you build the projection, which is ray tracing. Cool. In this case, you have two objects, right? So this object is blocking the ray towards the light, yes? So that means shadow, right? So you will have no light, so you'll have a dark point or some kind of dark point. Does it make sense? Here we will have a bright point. And it makes sense, well, it's bright, you can see it, yeah? Does that make sense? If this was a ball, it would make sense, yes? Bright shadow here. Cool, so you do this for everything, and then you'll have a projection of what you were kind of looking at. Sounds good? In this book, you will see C++ code to do everything we say, which we will not go into because you are not doing a specialty on But if you wanted to build this ray tracing, and for example, all the colleges in the USA that teach animation as a full specialty, all the students must build a ray tracer in C++. You build your own ray tracer. And at the end of the chapter, you'll see code for ray tracer. It's only 50 lines or something. It's quite simple. You just need to, it's a matrix, right? And then you build your own ray tracer. It's like, wow, it's like your own Maya studio. It's C++. Here you have the matrix, the loops, and how they did. I didn't go into it, but it's very simple stuff. If you make this work in your computer, I'll give you 10 bonus points. But it's C++, so be careful. Right. Another important thing, it's not enough to do the ray tracing, looking at the light. It's also important to look at the transparency of the object. That means that when you trace a ray to a point in an object, not only you have reflection, some objects are also semi-transparent. Like, for example, glass, bottle of water, right? So that means that some light will come from inside the object. Does that make sense? So usually you have various things going on to make something realistic. That goes for the skin. Your skin also, it doesn't look real if you don't add translucency to the skin, the translucency component. Does it make sense? It's super important. Like, the light goes into your skin and kind of goes back, and if you don't do it, the skin looks uncanny valley. Does it make sense? You don't believe me? Wait, I'm gonna make a demo. Yes. You believe it now? It's pretty translucent, actually, the skin. It is very translucent, right? So if you don't add translucency to the camera, if you don't add translucency, it doesn't look so good. Okay, so in this case, we have a source of light here. So if we do ray tracing, we'll have. Also, there's another problem with ray tracing is that all the light doesn't, sometimes the light doesn't come to you directly as a bouncing from the ray of light, from the source of light. It comes from light that bounces in an object which is near the other object. Have you seen the TV photos where there's a guy holding something white? Yeah. You've seen that? That's like, this is it. So it really affects things. So if you have red objects near you, it will make you more red. Yes? So ray tracing becomes very, very complicated because there are so many bouncing, right? So how many times do I have to bounce this to make it realistic? Like, imagine I have a ray of light. This ray will go here, then it bounces here, here, right? So 2 bounces, right? But I could have another one that goes here, 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 and ends up here. 16 bounces. Or I could have another that goes into the room and then back, 32 bounces. After how many bounces, the picture looks realistic? So when I was a kid, the computers could do about 16 bounces max, and that doesn't look realistic. Okay? Can you think about it? The more bounces, it explodes in computational complexity. So the number of bounces is what makes it look real or not real, and it really makes a difference. Okay, and this one, if this is transparent, you will have the reflection loss playing in, and then you'll have some light coming through the object. So another example of a glass ball, just law of physics. I think one of these is fake. I don't know which one. Right, good. 2 more concepts. Yeah, here's the full code to write a ray tracer. This is it. Do you see it? It's not very long. It's only 66 lines. That's pretty good. And that's the output. Here's the full code of the class. Got it? If you build this, if you compile this ray tracer in your laptop, if you are using Mac, you have to install developer tools, and if you use Windows, I guess you have to install Visual Studio C++ something. If you make it, and you make it one render of one object, like a ball or something, bonus points. But, you know, it's a bit difficult. Questions? Questions? No? Okay, so now let's work a bit on your strawberry and see if we can finish it. And the next day we'll do the strawberry contest. You have any questions? I'm here. Hasiba, what are you doing? What's happening?
Make the lattice like that, but I don't know how to make it.
The lattice, you mean?
Yes.
You made it, no? It's here. The lattice is here. How do you rotate this, the camera point? Oh, yeah. It was like, how was it? Like, yeah. Okay, cool. Nice. Well, and you want to make it what? You don't like, that's not the lattice we need, right?
Yes, we want to make the radius here.
The what? The
radius.
Radius.
Yeah.
I don't know what you mean by that. Okay.
We want to make it like that. Make it small.
The radius of the lattice.
Yes. Something like that.
Let's see.
This one.
Oh, you want to deform it? Yeah, okay. What tool do they use? The magnet or what? I think you. Yeah, how do they do it?
They do it by.
Are you using the new tutorial? Yeah, not the old one. Let's see one.
The new one, yeah. I'm using my 2019.
Perfect, perfect. This is 2018 though.
Yeah. There is no 2019.
19. Okay, good. So show me what you're doing. Yeah.
We want to make it like a small one, but I didn't.
I understand. So don't we have to select the points first to do this?
This is the point.
The scale tool. But if you only select one point, it doesn't work. You have to select these points, no? Don't you think?
How can I?
So, well, I would go like this. I will go like this. This is what I do. Just take a view that it's good for you, right?
Okay. Close this one, sir.
No, it's okay. I don't want to select everything. Do you know how to select this only? You know what I mean?
Yes.
From here, you could select only this, and then you could. Does that make sense?
Yeah.
Okay. I'm pretty sure that's possible to do. I think we need to change the tooltip. Tooltip to select, which I don't know which one is it. Hold on. All software works the same way. Look, we have the magnet here also, which is pretty cool. The magnet provides no, we want this one. Snap the course, no. Snap the points, just magnet maybe. Make the server live. Ooh, no. Tooltip, what is the tooltip? Select, right, select here. Select by type, inverse, grow, components. I don't know how they do it. Oh, maybe the tooltip is here. There must be a tool selection that you do this and you can select the points only. But I forgot. Well, I never used it, so I don't know how to do it. So you can Google Maya how to select points. You should imagine selection mode F8. So you think you can press F8 here. Yeah, got it?
Yes.
Cool. Oh, that's looking good. So these points are selected now. So you need to remember the shortcuts. And now do that work, that thing you wanted to do. Oh my God, pineapple, a red pineapple. What?
I
What's the
think-
problem? Why it doesn't look good?
I don't know.
Damn it. Maybe the dips are too big, do you think?
You mean the hole?
Yeah. Shall we make it smaller?
I'm gonna try. Unfortunately, I forget my mouse at home.
That's a great excuse, but we have a mouse here, you can steal it. That's no excuse. Oh no, you have this new
Yeah.
Mac.
Yeah, that's why.
Well, so what?
So
You cannot work without a mouse. Okay.
No, I think it's too difficult. I just learned how to.
You made the leaves? Was
Yeah.
it difficult?
I make it with the cylinder.
And then what? You cut the cylinder?
Yeah. I
Really?
cut-
You
yeah.
cut it like that?
No, it was like. I think it's complicated a little bit, but it was easy.
I see. If it's far away, it looks good? No, it doesn't look good.
Actually,
I think the dips are too big. Show
yeah.
a
there's
strawberry. Show me a strawberry, normal one.
There's something. I will
Yeah.
tell you.
Okay. What?
That thing, that hole, that circle, I don't know why it's happened.
Ah, this circle here,
Yeah, this one.
the dip.
Not the deep, I mean that one.
Oh, it looks beautiful.
Oops.
Sorry.
That one.
Maybe this color is the problem. Maybe it should be dark green instead of this
Darker?
radioactive green.
I'm gonna try because
I think that's the problem. And maybe these seeds should be not yellow. It should be just more greenish, like the ones I showed you. Can you change this quickly, the
no,
color?
No, because I tried.
How?
See,
It should be super easy to change though. Why is
I
it not
have
possible?
to ungroup it first. I tried.
The leaves is not a separate object?
It was, but
It
then
was.
I grouped it.
Well, but still, the group information should be somewhere.
Yeah, I found it somewhere.
You
here.
merge it or you group it?
Mm,
There is
Right here, ungroup. See?
error.
It
Can I
has an
group
error.
leaf level transforms? Okay, well, no problem. So you can still. Hold on. Let's be smart about this one. Look, you can still select most of the leaves with. What is F8? Damn it! I hate this new Mac. What is F8?
I think you have to.
Can you select? You can select things, no?
FN or-
You can select these.
No, I grouped them.
Okay, but ungroup it. What?
See,
Are you
together.
serious?
Yeah,
We should be able to ungroup, no? Wait,
yeah. When I see, like, I think it's an edit.
go on, go on.
Edit. Ungroup.
Preserve position. Apply. Ungroup. Error. Can ungroup leaf level transforms. What does that mean? What?
I think I
Ungroup.
prefer to.
Let's not ungroup it then, but can we select and at least.
No, we cannot.
What did you do?
I just group them
Why did you do it?
because that's what the tutorial.
Set
Yeah,
as a last step or what?
yeah.
Can you go back? No.
No.
Control Z? No. We still should be able to select one polygon and paint it.
Yeah, I'm gonna try.
Let's do that because it's not so much work.
All right.
From here it's super easy, like da 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 da, boom.
All right.
Does it make sense?
Yeah.
I think if you change the color to normal green, it would, open a picture of a strawberry next to you, and then you can.
All right.
I think that's what people do.
Yeah.
Pixar. Great, excellent. Questions? Oh, beautiful, beautiful. It looks so perfect. It's nice color, very good. I would eat this strawberry. Yeah, don't deform it if you don't want, yeah, it's beautiful, very nice. Yeah.
See, the seeds are yellow.
No, they're green, excuse me.
Doctor,
No way.
come on.
Well, look at these ones. These ones are green, and I think they look better.
All
These
right.
ones are green. And look, but at least the leaf,
All right. I'm gonna try.
It looks like Shrek now. Let's see. Interesting. Hulud, you okay? All good? How are you? Good? I think the dips are too big, but in general, in the tutorial, I think we could make it smaller and it would look better. What do you think? You think no? Yeah, maybe, right? Also, it looks like the gherkin sometimes. How are you doing, Aliasia?
I'm doing it like for the fifth or sixth time.
Really? Why? What happened?
I like to do things repeated, so it's okay.
That's a great strawberry picture. You could share it on Slack. It's really good. The one you have, yeah. It's very good. Raya, look. This is the most realistic strawberry I've seen. Looks real, right?
Yeah.
Yeah, that's what we want.
30?
Yeah. Bummer, this merging of the lips with the object, it's not cool because you could have then copy the lips
Yeah, I'm gonna try.
in other objects. Damn it. Huh.
But I think I'm the first student that I made. They finished it. So.
Yeah, you're the first. You get bonus point for that. Good job. Is there a source of light defined there in Maya right now? Did you put a source of light, like a light somewhere, or no?
No.
No. Awesome. How's the iPad going? Did you test it more? No, it's okay.
I'll show you.
Ah, you want to show me? Does it improve your productivity?
Of course.
Like 2 times, 3 times,
More maybe.
4 times? Okay, we have another one, so.
This character.
Oh, wow.
I don't know where to use it.
Oh, you're using this software. What's the name of this software?
No, this one is
Sketches. Yeah, use
This
it too.
one is,
Right. You use the sketches and then you put it here? No, that's for you to work.
yeah.
This is so cool. I'm gonna take a picture, okay? I may use it. You might be famous in my next book. This is a great idea.
I want to make them more.
I see the characters. They're great. They could hold hands. And what does this represent?
Like they are talking.
Ah,
Maybe
damn
I
it.
put it like in a bubble, maybe.
That's very good. I think if you put a normal bubble, people will be more familiar.
Each one of them.
Or a connected one to a cloud,
Ah.
all of them. And then you can put these inside the cloud.
Yeah,
Does that make sense?
yeah.
Because I thought they were like eating a spaghetti or something.
Because I found like a picture. Looks like this. I didn't use it. This one.
Yeah. That's really nice. But sometimes nice is the enemy of easy to understand.
Yeah.
You will find this problem all the time. So I like the eyes. You're playing with the eyes very well. And each character has its own character.
Yeah.
Remarkable, like that principle of,
I wanted
except this one,
to be-
future.
I wanted it to be different than the rest.
But it's not,
It's
right?
bigger.
Because this one is what, neutral, worried, emotional, and
It's
this one
like
happy,
not happy. It's
sleepy.
Like your future is screwed.
That's the eyebrows of, these are the eyebrows of everything is great, right?
It's like their eyes.
Bliss. Oh, what is it?
You know the emoji.
I know the emojis, but
yeah. Same.
I got it. Can you dramatize them a bit more? Maybe that's the problem. The future maybe could be more dramatized, but I don't know how.
How about this one?
And what about this one? The stern face. This one could be interesting. At least it would be remarkably different.
Yeah.
There was one that looks at your eyes fixedly, like this. Like this one.
Yeah. Yeah, this one. Yeah, maybe it sounds like that.
Not sure now. Or
Oh, this one.
doubting? Yeah, actually, yeah. Anyway, it's pretty good.
Yeah.
Very good. How's it going? What about you? Is it going well? You have so many stickers here. Right.
I did it again.
You start again from zero? Why? What
Because
happened?
I didn't know how because it's like it had sharp edges, so I'm doing it.
You could not control Z and go back?
No, there were so many.
Okay, that's fine. How are you doing, girls?
My laptop switched on.
Okay. I'm sorry. You can go to the lab and work there in the lab, in the mega computer they have, if you want.
No?
Yeah, if you want. Follow on Slack what we're doing. You can ask questions. Go to Fadi's lab. There's
But I already did my work, so I'm going to do it from.
oh, I see the problem. So why did it shut down your laptop?
It doesn't
Huh?
have a charger. No charger.
You have a charger.
No, I don't have a charger. now.
Which kind of laptop is it? Is it a Mac?
No.
Okay, forget it. Just help. Why don't you help Kasiba? I think she needs help. Kasiba, I assign you a student. Can you work together for today? Yeah. Did you change the color? No.
No, I searched and they told me that the same steps as I did.
It doesn't work.
agree.
Yeah, you will find this. You will find this very often. So don't get mad. The software is very complex, and I've seen experienced people not able to fix problems. So this is super normal. You know what I do? I save my work in different versions,
Yeah.
and then because it will screw up at some point, so that at least I have versions to go back.
Yeah.
Every 10 minutes, I will change the name. 1, 2, 3, 4, 5, 6, 7.
I think I did it here. So really like.
Right, but not enough, yeah?
Yeah, of course.
Do you want to load that one and see what you have?
See?
Got it. Yeah, that's a problem. I put a timer, so every 10 minutes it will buzz and say, time to save. Yeah, it's funny.
Can I leave now?
Yeah, sure. Bye, Raya. Ciao.